Hello and welcome to the ISC 11 Maths tutorial. Today's topic is differentiation. We are going to learn how to differentiate using first principles or using definition. Okay, so before we start, आइए आपको एक शायर की दो लाइन सुनाता हूँ. सुनिए शायर क्या कहता है. शायर कहता है, यही है इबादत, यही है इबादत, यही दीन व ईमा, यही है इबादत, यही दीन व ईमा, के काम आए दुनिया में इंसान के इंसान. Thank you. Now let's start. We are going to learn how to differentiate. Today's topic is to differentiate using first principle. Now the first question is, the function given is, and the question is from your exercise, from your ISC book. The function given is 2x. 2x. You have to differentiate this using first principle. So how do we start? We write down let fx is equal to, we write down let fx is equal to 2x. Let fx is equal to 2x. Alright, this we are supposing. Let fx is equal to 2x. Now, by definition means, there is one formula that I am giving you. F dash x is equal to, the formula is f dash x is equal to limit h tending to 0 fx plus h minus fx upon h. That means we have to find out the limit, and the limit, you know, how to find out the limit, you know. If you find out this limit, that is the derivative of fx, which we write down f dash x. F dash x means the derivative of fx, differential coefficient of fx with respect to x. F dash x means, I am telling you what is the meaning of f dash x. F dash x means the derivative of fx with respect to x. F dash x means, again listen, the differential coefficient of fx with respect to x. And this is equal to, this is what we have to find out. This is what we are going to find out. Fx is given. In the question, fx is given 2x. We have to find out f dash x. And that f dash x is equal to this limit. That means simply we have to find out the value of the limit. Okay? Where we want fx plus h, fx, and then whole divided by h. Okay. Let's write down the values. Fx we have, we'll find out fx plus h, and then we'll substitute here. So fx is 2x given. Fx is equal to 2x given. Alright. Fx is equal to 2x given. This is given. Now we find out fx plus h. Fx plus h. So fx plus h. And this is equal to, in place of x we'll write down, x plus h. X will be replaced by x plus h. So 2x plus h. 2x plus h. X is replaced by x plus h. Fx plus h. Now this fx plus h and fx will substitute here and we'll simplify. We'll find out the limit. That value will be the derivative of fx, which is f dash x. Okay. So therefore f dash x is equal to, f dash x is equal to, f dash x is equal to limit h tending to 0 fx plus h. Here you write down fx plus h minus fx upon h. fx plus h minus fx upon h. Fine. The same formula I've copied once again. Now that is equal to, this is equal to what can we write down? This is equal to limit h tending to 0. Okay, let me write down limit h tending to 0. Limit h tending to 0. Fx plus h means this one. Fx plus h is this, 2x plus h. Okay. That we can write down whole divided by h down. And here we write down 2x plus h. So 2 and in bracket x plus h. Alright. X plus h. And then fx minus fx minus fx. What is fx? Fx is 2x. So we write down then 2x. And that is equal to, this is equal to limit h tending to 0 h. Now open the bracket, 2x plus 2h minus 2x, right? So we can write down 2x plus 2h and minus 2x. Now this 2x and the 2x cancel each other. This 2x and this 2x, they cancel each other and we get 2h upon h. So we write down then is equal to limit h tending to 0, limit h tending to 0 and then 2h upon h, 2h upon h, h cancel and then you get is equal to limit h tending to 0, 2. Limit h tending to 0, 2. There is no h. This h and this h cancel each other. And here because there is no h, so simply 2 is the answer. So then you are getting 2 as answer. This is the answer. This is the answer. So 2 is the answer. Got it? Okay, now next question. Question number 2. Question number 2. Question number 2. Next function, again we have to differentiate using first principle or using definition by definition. And the next question is, okay, question number 2 I am giving you as homework. Fx is equal to x minus 1 whole square. This question I am giving you as homework. You please do try at home. So fx is equal to x minus 1 whole square. This question I am giving you as homework. And answer also I am telling you. Answer is Answer is 2 x minus 1. Answer is 2x minus 1. This you please do at home. Fx is given, find out x plus h, and then in the formula substitute. Try to simplify. Try. Please try to do it. This is a question number 2, which is your homework. Please try at home. Now question number 3 I am doing. Question number 3 is 1 upon root x. Question number 3, this I am doing. Question number 3 is fx is equal to 1 upon root x. Fx is equal to 1 upon root x. This we are going to do. fx is equal to okay. So fx is given. Now let us find out fx plus h. This is x. Fx is given. Let us find out fx plus h. So f x plus h. Now this is equal to 1 over root x will be replaced by x plus h. So x plus h. Alright, this is fx plus h. Now in the formula, we will substitute fx plus h this and fx this. So since, therefore f dash x is equal to, we can write down f dash x is equal to limit h tending to 0 fx plus h minus fx upon h. Fx plus h minus fx upon h, limit h approaches 0, h tending to 0. Now let's substitute the values. Fx plus h is this, fx is this, and then let's simplify. Okay. So this is equal to, can I write down here? Okay, let me try. Is equal to limit h tending to 0 fx plus h. 1 upon h I am writing like this. See, 1 upon h I am writing like this. And now in bracket I am writing fx plus h, which is 1 upon root x plus h. Alright. And minus fx, which is 1 upon root x. Got it? Is that okay? Fine. 1 upon h I am writing separate, and fx plus h is this, minus as it is, fx is this. Okay. Now let us simplify. Let's simplify. So that is equal to limit h tending to 0, limit h tending to 0, 1 upon h, and here the LCM will be this into this, okay? So LCM will be root x and root x plus h. This is the LCM. Alright. And up we'll get root x minus this. So root x minus root x plus h. Simple subtraction, x plus h. Fine. After this, all these things you have learned when we were doing limit, how to find out the limit. So we'll multiply by the conjugate of the numerator. We'll multiply by the conjugate of the numerator. Alright. So that is equal to limit h tending to 0 root x minus root x plus h, root x minus root whole divided by root x and then root x plus h, and we multiply by the conjugate of this. A minus b conjugate is a plus b. Alright, so we multiply by root x plus h, root x plus root x plus h, root x plus root x plus h. We are multiplying by the conjugate. Now maybe one question is there in your mind, why are we doing this? Why are we multiplying by the conjugate, and when should we multiply? When should we do this? How will you come to know, how will you decide? How to decide that we are going to multiply by the conjugate of numerator, sometimes by the conjugate of the denominator maybe. So the answer to this question is actually when you put here h is equal to 0, right? So suppose you are putting h equal to 0 here. So this you are getting indeterminate form. This you are getting indeterminate form. See, when h is 0 here, h is 0 here, when you put directly h equal to 0 here, you will get root x. So root x minus root x, which is 0, fine, and down you will get root x into root x, which is x, so 0 upon x, alright, and h is 0, so 0 upon x, but h is 0, so 0 into x is 0, so 0 upon 0, 0 upon 0 is an indeterminate form where we have to find out the limit, 0 upon 0, alright, that you must have been taught when you were doing limits. 0 upon 0 is an indeterminate form. So because we are getting 0 upon 0, we don't want that. We don't want 0 upon 0 form. We don't want infinity upon infinity form. They are the indeterminate form. That's why we are just trying to avoid that. We don't want that 0 upon 0 form. So that we can do by multiplying by the conjugate of the sometimes denominator, sometimes numerator. It is here by numerator, and let's see what's happening. How are we going to get the result? See, we are multiplying by the conjugate of a minus b, which is a plus b. The conjugate of a minus b is a plus b, right? Now what happens when we multiply? See, a plus b and a minus b, which is a square minus b square. So a square means x and b square means x plus h. Let me write down, then you'll understand. So this is equal to limit h tending to 0, a minus b into a plus b, which is a square minus b square. A square means root x square. So because we are in 11th standard, so 11th and 12th, we don't have to show that root x whole square and then root x plus h whole square. If you wish to write down that step also, please, you may write down. I am writing directly. If you wish to write down, you can write down. I am writing a minus b into a plus b is equal to a square, means root x whole square, minus b square means root x plus h square. Alright, so this step I am not writing, you may write down. I am writing directly when we are writing square, so this becomes x. So x. I am writing directly x. Actually this square, no, root x square, which is x, minus a minus b, a plus b is a square minus b square. So square of this is x plus h. X plus h. Got it? So a square minus b square, and whole divided by root x as it is, then root x plus h as it is, and then this also into root x plus Okay, this is in product, this into this into this. Okay, now when you open the bracket, this x and minus x, they cancel each other. This x cancels this x and you get minus h. Alright, I think one thing we missed out, 1 upon h we didn't write down, so this 1 upon h should also be there, no? This 1 upon h, so that I am writing here, h tending to 0, and this 1 upon h should be there, no? That we forgot, 1 upon h, this 1 upon h, so that 1 upon h here also, h tending to 0, and here 1 upon h, 1 upon h. Alright, fine. Now x minus h. So once you open that step, you can write down, open this x minus h, and then whole divided by everything, again copy. I am writing the next step after that. So x and x cancel and you get minus h upon this total. Again minus h upon, okay, let me write down. So then you are getting is equal to limit h tending to 0 minus h whole divided by h. Which h? This h, 1 upon h. This 1 upon h, I am writing like this, h, and then root x, and then root x plus h, and then this one, root x plus root x plus h. What do you say? Fine. Now this h and this h one's a h. So you are getting minus 1 upon that. Also one step you can note down. After can say minus 1 upon this, that you note down, and then after that you can put the limit, the value of h as 0. Now let us see if we are getting 0 upon 0 form or not. We should not. We will not. That is equal to, now you put h equal to 0. So when you put h equal to 0 here, this becomes root x into root x. So minus 1 upon, this becomes root x into root x, and in this bracket you get then root x, and here again you get plus, h is 0. So root x plus 0 means root x. Okay. Fine. Now limit disappears because we put h is equal to 0. Now you please don't write down limit. Some student, they put the value and then also they write down limit here. No, the job of the limit is over. Limit h tending to 0 means h equal to 0 we have substituted. Now this is equal to minus 1 upon root x into root x is x, agreed, and root x plus root x is 2 root x. So you are getting 2 root x. Like this, if you wish to write down, you can write down in within bracket. Now no need, but if you want, you can write down. And this total, then you can write down minus 1 upon 2 x root x, minus 1 upon 2 x, and then root x. Or you can write down, see, x root x means half and x means 1. So x raised to the power 1 plus half. 1 plus half means 3 by 2. This is your answer. This is also okay. This is also okay. This is also okay. You can write down that also and this also. This also okay. Either this or this. Alright, so answer is this or this. Fine. Now one more question you write down as the homework. The question is fourth question. Question number 4, homework. I hope everything is clear. Question number 4. Question number 4, function is given. I am writing directly fx is equal to it's given, comma, fx is equal to 1 upon root x plus a. 1 upon root x plus a. This is our question. And answer if you want, I give you the answer. Minus 1 upon 2. Answer is minus 1 over 2 x plus a, x plus a. X plus a and root x plus a. Oh, fine. Or you can write on 2 x plus a raised to the power 3 by 2. Because half this and 1 this 3 by 2. Okay then. I hope things are very, very clear. Okay then. Thank you so much. Thanks.